Okay, Rick, we are now live on YouTube, and pardon the noise in the background. We have the 1400 drawing going on right now in the same room. So it's all yours.
Well, good afternoon, Dean. I appreciate Dean Groen being my moderator. And good afternoon to all of you who have come. Thank you for listening. And in turn for your time, I'll try to give you something to take away in the next 45 minutes. My name is Rick Rikoski. I'm W9ZD. I'm a ham and an engineer. I'm going to do two things today. I'm going to cover the basics to get on SSB with a wire antenna so that you can rag chew with people you've never met before, but who share your interests, join nets, join contests, and talk across the USA, Canada, and across the oceans. This means I'm going to cover very briefly the ham bands, antennas, propagation, radio noise, and clear up some misconceptions on CV, standing wave ratio, and coaxes. These are the important things that you'll need, besides money, to get into ham radio. So we have a long way to go and a short time to get there, so let's roll. I have two ham shacks, one in Beverly Shores, Indiana, one in Oak Brook, Illinois. I run an engineering forensics company. I'm an electrical and mechanical engineer. I have a doctorate in applied space sciences from Carnegie Mellon University, but that was a long time ago. Today, it's a fast run through the basics. Misconceptions will be those of standing wave ratio, coax losses, and the necessity to have 120 radials when using vertical antennas. To start with, somebody once asked Albert Einstein about if he could explain radio. Einstein said, wireless telegraph is a kind of a very, very long cat. You pull his tail in New York and his head meows in Los Angeles. Well, radio operates in exactly the same way. You send signals here, they receive them there. The only difference is there's no cat. There's magic to all of this too. And I think it's important as a ham to never lose sight of the magic. I'm caught up in the magic of being able to talk to somebody across the ocean using an aerial that I put up with my own hands in my own backyard. I'm the beneficiary of the work of some well-known radio inventors. We all know about Hertz, Marconi, Fessenden, and Armstrong. But there's three other ones too that you should be aware of. Alexander Popov, who is a Russian, who did work in the late 1800s, Nathan Stubblefield from Kentucky, and Father Joseph Mergus from Pennsylvania. My wife Carol and I have done tours of the Marconi sites on both sides of the ocean. One year we went to Poldhu on the Cornwall coast of England, and we looked at the site that Marconi used to transmit his first telegraph messages to ships at sea. And this is called Poldhu. Of course, the towers were not there at the time that we looked at them. Neither was his ham shack, but there were Frenchmen on the nude beach across the way. Father Mergus in Pennsylvania had two giant towers in Wilkes-Barre and two giant towers in Scranton, and he communicated over dry land using these towers. To get into the meat of this talk, there's 4 books that you should have. You should have the National Electrical Code, the ARRL, Radio Amateur's Handbook, which now is kind of an encyclopedia, the ARRL Antenna Book, and a book out of Germany, which you can get on Amazon or from the Deutsche Amateur Radio Club It's called Rotham's Antenna Book. You can get that book in many languages, including English. It costs about $60 and it contains over 100 pages of antennas and antenna designs. It's a very practical book. And I bought mine when it was in German only. And they've done a lot of work and they've translated into many languages, including English. There's hams that have published extensively, and I'm the beneficiary of what they've done earlier on. One is L.B. Seebeck. Unfortunately, he's deceased, but his family has made available his work on disc. And you can find all three of these people on the internet: Rudy Severns and of course Joel Hallis, who writes The Doctors in every month for QRZ. And anytime you have a question, you should always remember to go to Wikipedia or your browser, and you can probably find something online. If you're contemplating buying something, you should look at eham.net because it maintains extensive online user reviews of equipment and services. So let's begin with a tour of the ham bands. The bands used by amateur radio are not just numbers to memorize for licensing exams. They're entities with individual characteristics that determine how they can be accessed and used. There's two bands that I'm not going to talk much about today. They're relatively new. These are low frequency bands at 2200 meters and 630 meters. They have wattage restrictions on those bands, but you can use SSB on them. I don't have experience with these, so I'm not going to talk about these. The other low frequency, or actually medium frequency band, is the 160 meter band. It requires large aerials. So if you have a large lot, you can use these. There's also some other ways of reducing the size of these aerials. They're popular for regional communications at night, and like the AM radio broadcast band, they have relatively local range during the day. The 80 meter band is a good compromise. The antennas are shorter. It's longer distances than the 160 meter band. For both 80 and 160, you need a general or a higher class license. There's the 60 meter band, which has channelized limitations, 5 discrete channels. There's power, antenna gain, and carrier frequency limitations on that band. The 40 meter band is a very good band. You can get on that band with a 66-foot dipole. It's reliable all seasons. It works 24 hours a day. The ranges change a little bit. Again, you need a general or a higher class license for this. My favorite band is the 20 meter band. It's commonly a cross-country band. It can be transoceanic depending on band conditions and also on the height of the antenna that you're using. It's a daytime band in the wintertime and day and night in the summer. You need a general license for that. And the band limits expand as you get into a higher class license. There's 3 other bands, 17, 15, and 12. If you have a 40 meter dipole, it also will resonate on 15. These are worldwide bands when they're open. They're greatly affected by sunspots. My experience is that they're pretty dead right now. Again, you need a general class license. The 10-meter band, when it works well, it works extremely well. It can be very long distance. The antennas are relatively short. The dipole is 16 feet. It's amenable to using whips, dipoles, and beams. It's primarily a local band, but if the band is open, you can go around the world. It's also a band that's very popular with new hams coming over from Citizens Band because the frequencies are roughly the same. And because of that, you can find cheap accessories at any truck stop. So that's worth thinking about. Technicians are allowed on the 10-meter band with a power limitation of 200 watts. 6-meter band, it's one of my favorite bands. Small antennas, 9-foot dipoles. It's similar in characteristics to what channel 2 used to be. Because the 6-meter band is 50 megahertz, channel 2 was 54. When the band opens up, you can easily do 1,000 miles by sporadic E-skip or 1,500 to 2,000 miles by F2. It's a band that's impacted by sunspots. In Illinois, DuPage County, we have York Radio Club, which has a Monday night net that meets on 6 meters. And about a month ago, we had somebody come on the net that we didn't know, and it was somebody from Miami, Florida. That person was able to get into us through F2 skip. So even though the 6-meter band has been dead because of sunspots, lately it's opening up. So it's certainly something to be thought of. People call it the magic band, and I think for good reason. I want to get into a misconception about S units for a moment. Received signal levels are commonly stated in S units. An S unit, there's an equivalency 6 dB of change in signal level is the same as a 1 S unit change in signal level. And just looking at dB for a moment, a 1 dB change in signal level is barely perceptible. So if you're thinking about changes and spending some money to get a change of a dB or 2 in something, don't get caught up in a difference that's that small. So a 1 dB or a 0.6 of an S unit change is barely perceptible. Let's talk about some antennas. First antenna is the vertical monopole. The vertical monopole starts out as a dipole, and it's a half wavelength antenna. So if we're talking about a 20-meter band vertical antenna, half wavelength is 10 meters, and a meter is roughly 3 feet and a little bit more. So for 10 meters, we're talking about 30 feet, 33 feet. Half of this would be 16 feet. So if you can get away with a monopole, you get away with 16 feet. And you have some other way that you have to restore the equivalent of the missing quarter wavelength. This can be done with radials or with counterpoises or with a simple ground. There's other things that make this attractive. You can shorten the antenna by using a loading coil, and Wolf River makes some very solid loading coils. These are adjustable, and they're very strongly built. I've used these, and they can be very effective. Here's the characteristics of the monopole. It's omnidirectional. Which somebody has once said that means it radiates poorly in all directions, which might be true, but it is omnidirectional. It does require radials or counterpoises, and you can get by with one or two of these, or none, depending on the coax shield. Have to be careful with radials and counterpoises, because exposed radials or counterpoises present a shock hazard unless buried or elevated. And the shock hazard depends on the power output of your transmitter, but it can easily be 1 to 3,000 volts. So it's a serious shock hazard. To get around that, you either bury the radials or you raise your counterpoises so that they can't be contacted inadvertently by people while you're transmitting. Because the antennas are vertically polarized, they're generally noisier on receive, because noise is generally more vertically polarized. Some people use monopoles on their cars, and these are called screwdriver antennas, and it's possible to tune these even on things like the 80 meter, 40 meter bands, using a relatively short whip to an SWR of about 2 to 1 or better. The one thing that's lost sight of is the fact that these antennas are not very efficient on the lower frequency bands. And for those bands, you can lose something like 90% of your power. The vertical sometimes can be bent into something called the inverted L. I find this to be a very popular antenna on 160 meters. When I had a ham shack in Wilkes-Barre, Pennsylvania, it was downtown. I had a house that was right in Center City on a very narrow lot. The house was 35 feet high. So I put up a wire antenna that went up 35 feet and then went across for the rest of it, which was about something like 85 or 90 feet. That antenna is an inverted L. It's also called a Marconi. And the bottom end of the antenna goes to radials or counterpoises. I used 4 counterpoises raised at 8 feet so that people couldn't contact them. Inverted L, it's a bent vertical that has both vertical and horizontally polarized signal components. And it is a good way to get on 160 on a small lot. The feed point for the antenna is at the bottom, which is a mechanical advantage. It's amenable to stealth, and I certainly used that in Wilkes-Barre to get around neighbors' concerns. If you can't see it, you can't get bothered by it. You have to be careful to avoid certain lengths which cause high SWR problems at the higher bands from the fundamental. For example, when I was doing my antenna in Wilkes-Barre, I wanted to cover the 160 meter band. So for the 160 meter band, a half wavelength is 246 feet. But this was a quarter wavelength antenna, since it's a bent vertical. And that would put it at 123 feet. Problem with that is the SWR on the 80 meter band is very, very high, and I couldn't tune it on the 80 meter band. All the rest of these bands worked fine. So what I had to do is to reduce the length of this antenna by 5 feet, which meant I needed to use a tuner on all of the other bands. That's something that you should have in your junk box. It's a good tuner. You'll use it sooner or later. On radials, both the vertical monopole and the inverted L require radials or elevated counterpoises. The common wisdom is that 120 buried radials are required. And this is an old wives' tale that goes back to the days of AM radio. Someone was putting up an AM transmitting tower, which is a monopole, and the design engineers were very conservative, and they said that this person needed 96 buried radials. So they bought wire, and they bought enough wire for 120 radials. And they got the 96 in, and they didn't know what to do with the rest. So they buried the rest of the wires. And from that time onward, the misconception grew that you really needed 120. As a matter of fact, you don't need 120 at all. Do you need any? Do you need to dig up your backyard? Do you need 120 resonant radials or counterpoises? Well, L.G. Seebeck, before he died, ran some tests. He built an inverted L antenna. He did this on NEC, did this as a simulation, 50 foot high and 80 foot long, 50 foot of elevation, 80 feet for the horizontal section. And he ran 2 sets of tests, one with 4 radials at 135 feet long each one, and another set where he still kept four radials, but he did these with 20 foot long radials. I don't know about you, but I don't like digging up my backyard and spending all day doing that. And as I get older, I like doing this even less. So here's the difference. He went and measured the gains of these antennas. For the frequency starting at 80 and going higher, there was no change in gain with reducing the size or length of the radials. At 160 meters and going from 135 feet to 20 foot long radials, he had a difference of 0.4 of a dB, which would make absolutely no difference at the receiving site. He then went and got rid of 3 of the 4 20-foot radials. And he found for any band but 160 meters, there was absolutely no change. There's no change in the takeoff angle of the signals coming out of these antennas. And there was a serious difference of 3 dB on the 160 meter band. But 3 dB is 1/2 of an S unit. Is that a serious loss? Well, you can still get on the band with 1 radial. You might not be very effective at it, but maybe it would suit your purposes. And you only have to bury 1 20-foot long radial. I tend to prefer not digging up anything, so I tend to use counterpoises. These are essentially elevated radials. For most of my antennas where I've done monopoles, I've used 4 short counterpoises at an elevation of 8 feet instead of what's commonly done, which is 16 or 20 buried radials. The difference between this and this is less than 1 S unit at the receiving site. And my references for these are published papers by Seebeck and Severance. Let's go into the dipoles. There's a variety of dipoles. The classic dipole has a 1-to-1 balun and then a 1/4 wave monopole on each side of the balun. If you can't fit a 1/4 wavelength half dipole on either side, you don't have enough room, you can always let some of it droop. My favorite antennas are the off-center dipoles. These things are also called windums. In this case, instead of having the balun be at the center of the wire, it's offset. And what this means is that if you adjust things properly, you can get this antenna to be resonant on a lot of other bands besides just the fundamental. In this particular case, you go either a quarter of the way or a third of the way, and you see what you get depending on elevation and a few other things. The balun is what's called a voltage balun, and then at some distance from the receiver, put in another one-to-one un or choke. Let's talk about windums. The original windom was a single wire aerial and lead combination that fed directly to the transmitter. Problem with that was it let RF into the ham shack, so you could get shocked. And it also was amenable to causing radio frequency interference. Lately, the word windom now means a coax with a 4-to-1 current balance. That's often added. The actual balun ratio, whether it's 4-to-1 or 6-to-1, depends on elevation. The degree of offset sets the number of bands that this antenna is resonant on. There's also the Carolina windom, which is popular. It adds a 10-foot or 22-foot vertical radiating section, and also the Fritzl, which is popular in Germany, Netherlands, and the rest of Europe. Let's take a look at these antennas. A 260-foot long off-center dipole. This is my main antenna in Indiana. I have enough room to actually have a full-size 260-foot, 160-meter off-center dipole. On the 20-meter band, 40 feet high, this antenna would have a range of 1,300 to 3,600 miles, depending on band conditions. But I can depend on the 1,300. Carolina windom, and I have in DuPage County, my wife and I bought a second house here. Just before the snow set in, I had a 40-meter Carolina windom in my junk box. I put this up, and it's 25 feet on one side, 41 feet on another. In the center here, it only goes up 20 feet. So I didn't have enough time to go with slingshots and get halyards over tree limbs or put up a tower or even put up masts. So this antenna has a 4-to-1 voltage balun in the center and 3 radiating sections. There's a 25-foot section here, a 41-foot section here, and a 10-foot vertical radiating section. And to stop the radiation, I have a 1-to-1 choke here. There's another way you can do this. You can make your dipoles smaller by using traps. The problem that you have to be careful of with traps is that they are RL resonant circuits, and they tend to be rather high Q and tend to be narrow bandwidth. Let's go back to the off-center dipole for a moment. You have a 130-foot long off-center dipole, 20 feet high. It's a peak takeoff angle of 50 degrees and a range of 500 to 1,700 miles. You can use ladder lines. There's dipoles that use ladder lines. There's a very popular G5RV, the dipole doublet, the broadside doublet, and the ZEP, which is short for Zeppelin. These were monopoles that were used to communicate to and from Zeppelins. The G5RV, the chief advantage of the G5RV is that it's short. For the base frequency, it's shorter than a simple dipole. There's three sizes in the G5RV. The classic size, which covers from 80 meters on up. The antenna is 102 feet long. It's not 130 feet long. So it's a little bit shorter. Depends on a matching section, which is a section of ladder line, which is 31 feet long. It's a double-sized one, which goes down to 160 meters. It's 204 feet. It's no magic here, this scales. And the ladder line section is 62 feet. The problem with that is that you have to be up 62 feet or be able to run a 62-foot angle to accommodate the ladder line section. A very, very popular antenna starts with a 40-meter band. That's the G5RV Junior. I bought one of these 2 years ago in Orlando when I was down for the hamcation. I bought one for $15 that somebody was selling, put the thing up. It's a very nice antenna. It's 51 feet long. It covers all of those bands, and the ladder line section 16 feet. I like the G5RV. It was designed originally by a guy named G5RV to run primarily on the 20-meter band. He had a small lot somewhere in England. The antenna requires a tuner, and it requires that ladder line section. So the ladder line section kind of knocks it out of the park in terms of being able to be stealthy. It's not very stealthy. You can see this antenna, but it's a very simple one. It's a short one. If you don't have problems with neighbors, petty neighbors, and you do have a tuner in your junk box, it makes for a very nice antenna. Is also the beam. This is the beam that I have in my backyard in Beverly Shores, Indiana. This is called a tri-band beam, 20-meter band, 15, and 10. There's sets of traps in the dipole to make the thing shorter. Remember, this whole thing is up in the air. It's designed for the 20-meter band. 20-meter band means 10 meters in theory across the width of the dipole. So 10 meters of that would be 33 feet. Well, that's a lot to put up in the sky. So the dipole is reduced through the use of traps. So you can see the traps here on the dipole, also in the reflector and in the director for the beam. That's a tri-band beam. You can buy these. Mine's a Cushcraft. It's an old one that I bought used, again at a ham fest. I wish that there were ham fests. I mean, real honest to God, where I could buy used equipment at ham fests. I bought this one from a guy at the LaPorte, Indiana ham fest. He sold it to me for $150. I took it home. I disassembled it. I cleaned all the connections and put the thing back up. There's another beam here, which is this one. This is a Create log periodic. It's made in Japan. Resonant frequencies here go from 50 megahertz up to 1.3 gigahertz. This means I can use this thing on the 6-meter band as a beam. I can also use it for anything else I want in that range too, including to watch TV, because it covers all those bands. And it covers 440, it covers 2 meters. I hesitate on that because those things are generally vertically polarized. And this is a horizontally polarized antenna, the way I have it set up. The 6-meter involvement doesn't seem to matter much because once signals are reflected from the ionosphere, the polarization information tends to be lost. So this antenna works very well for me on 6 meters. The beam has a gain of 2 or 3 S units over a dipole. It's directional, which means if you have a noise source, you can null it out because it's horizontally polarized, diminish the noise pickup. The disadvantage is it can be large and cumbersome, and it's susceptible to damage due to high winds and icing conditions. On receive, I also have, in Indiana, I have a Pixel receiving loop antenna. You can get this from DX Engineering. I bought it from the guy who started the company. I bought it from him at the Dayton Hamcation 5 years ago, 6 years ago when they were at Trotwood. It's a very nice antenna. It diminishes noise levels on the lower bands by about 5 S units. Then if you're in a very high noise area, the problem is there's not too much of a problem, but it also diminishes the signal levels by about 2 S units. But you still come out ahead on signal to noise because the noise is much less and you can hear things even though they might be a little dimmer. They're also transmitting and receiving loops. I bought this on eBay from a guy who was building these in Florida. These are resonant circuits. Signal from the transmitter comes to a small loop, which couples to a larger loop. And the larger loop is part of a resonant circuit with a capacitor in this box. The capacitor has to be a high voltage capacitor because the voltages are high. It has to accommodate that. And it's a very high Q RLC circuit, which means if you are tuning and retuning your transmitter, you have to run back and forth and turn the knob and make sure this thing is in resonance. Maybe that works pretty well in Florida, but in Indiana, where today it's 5 below zero, it gets stale pretty fast. You could spend quite a lot more money and get, I bought this thing for 150 bucks. You can spend a lot more money and have this thing automatically tuned. There's some wonderful transmitting loop antennas coming out of Italy, and we're starting to see them in the US as well. Let's talk about polarization. I'm starting to run out of time here. There's 3 layers. There's the D layer, the E, and the F. Signals come off of beams, go to these things. And depending on the angle coming out of the antenna, you can see the miles that are covered by various hops. Multiple hops are possible. It strikes me as magical in a way. A signal will bounce off the ionosphere, you go back and hit the ground, bounce off the ground and back up to the ionosphere. It's amazing. I'm going to skip these examples because I'm running out of time. Let's talk about SWR for a moment. You should not be concerned with SWRs below about 5:1, unless your transmitter is sensitive to it and begins to shut down power. So a reasonable figure for SWR is something like 2 to 1. If you're running SWR of 2 to 1, you lose 10% of your signal, which is not very much. Coax losses, again, on the 160, 80, 40, and 20 meter bands, 100 feet of coax, it really doesn't matter what you're using. It's not going to make much of a difference. For example, 100 feet of RG8, the dB loss is 1.21. That's barely perceptible at the receiving site. You can also use 75 ohm CATV coax with ham radio. The signal loss is 3%. Since it's quad shield, it gets better noise rejection on receive. So that's something worth thinking about. It's cheap. Grounding and bonding. Again, read the National Electrical Code for mains. When in doubt, follow the local electrical codes for your installation and maybe hire an electrician. For RFI, that comes from wall warts and LED lights. Consider using mixed 31 ferrites. There's a very good discussion of all of this online from Palomar engineers. Keep that in mind. I suggest also when you're buying equipment, buy an antenna tuner, an SWR meter, such as the Rig Expert, and buy toroids. I'm going to conclude here. I think an easy first antenna is a 33-foot dipole fed at the center, which gets the 20 meter band and higher, or a 66-foot offset dipole, which gets 40 as well. This is the sweet spot for getting on. I'll close with one thing. There's a freebie that you can get that I think is very nice to have and very useful. You can get an azimuth map centered at your location, courtesy of a ham, Tom NS6T. Can adjust the radius of the map, and it will actually let you know which direction your directional antennas are going in producing signals. My suggestions for newbies: read an internet search the ham radio topics you're interested in, find an Elmer, join a ham club, go to ham fests when they become available again, and get on the air with a low-end HF transceiver and a 20 meter dipole or a 20 meter monopole and some counterpoises, and experiment to your heart's content. If you have questions or comments after the talk is over, I'll be glad to talk to you on Rikoski or Rikoski.com. Again, thank you for your time.
Okay, Rick, this is Dean, and yeah, we've got some good questions here. If you could maybe back up to that previous slide so folks can see your email address, and maybe we'll keep that up there while we go through some of these questions. In fact, a couple of the initial ones were asking about contact information for you, as well as we have some folks that are curious about the presentation itself. If there's a way that you can make it available, you know, either as a PowerPoint or a PDF or something like that. I don't know if you have a way of making that available that you know of right now, or is that something that maybe people could email you about? We'll go with that as a first question.
I'd be glad to email them the PowerPoint deck.
Okay. So let's move up to the first question here, and there are some good comments too. Just general comments, but we don't have a lot of time, so we'll get right to the questions. Saul is asking, why do you leave the CW portions of the bands on the slides of the band limits?
Why do I leave them on the slides?
Leave them out is what he's asking. Why do you leave them out of those slides?
Because what I'm giving is essentially a 3-semester course in ham radio, and I focused on not on CW at all, but on SSB. I would have been glad to have done that if I would have had more time.
Yeah, understood on our limited time here. And yeah, just to let everybody know, we have another presentation coming up in this same technology slot here in less than 15 minutes. So we're going to get through what we can here. Bill Whelan has a couple of observations. First of all, congratulating you on a fascinating presentation and thanking you. And then he has a few questions. So his first question, which leads into another one, what are your two favorite tuners?
Oh, Palstars and Dentons for manual ones, and then the SGC automatics, because the SGCs are so wide range. They brag that they can tune anything, including a wire on 160. They claim to be able to tune an 80-meter dipole on 160. That's quite a claim.
Yeah, it sure is. And then his next related question is, where is a good source for those tuners?
Oh, I don't know. I when in doubt, I either like to buy things at Hamfest, but at a Hamfest you always have to trust but verify. Make sure that that you're buying something that's going to work. But when in doubt, DX Engineering.
Understood. Yeah. They and some of the other big vendors have most of those tuners. And then one last question from Bill. Where do you find the best quality toroids for the EFHW antenna?
Most toroids come out of Fairlight, a company called Fairlight. I like Palomar Engineering. They seem to have everything. They're not the cheapest place in the world, but you can depend on them. You have to be very careful with ham radio on the high frequency bands that you get the proper mix. And these are mix 31 toroids. If you get something else, they just won't have the induction that you need, inductance.
Okay, very good. There's two more questions, which I think you may answer both simultaneously. And after these questions came in, one of your slides addressed it, but I'm going to go ahead and send the first one your way here, Rick. Why does the Wyndham use a 75 ohm coax and not ham radio coax like RG8X, which is 50 ohms?
I don't, was that on the slide that I used?
Well, you addressed it in one of the later slides about using 75 ohm coax. So if you could maybe just expand on that.
Well, use any coax you want to use up there, and the losses won't be that great. But generally, you use ham coax for the Wyndhams. So I didn't mean to commingle them, but
Okay.
On mine, I use nothing but ham coaxes.
Okay, yeah, and then there was another question saying, why do you use 75 ohm coax? We were taught to use 50 ohm as beginners, and so sort of go in the same direction with that. And I understand where that question's coming from. Having taught a few ham classes, we typically tell folks early on to stick with 50 ohm before they get creative. But so another question kind of along the same theme there.
Well, the nice thing about the 75 is that it falls off the truck. I didn't say that, but you can get the stuff at very good prices, and the difference is it's 1.5 to 1 on SWR when you do that, and you pick up the advantage of This coax is usually quad shielded, so it's not as noise susceptible as ham coax. So there's some advantage to doing it, and it's cheap. I'm cheap.
Understood. Okay, so we have a longer one here. This is from Robert. He asks, I've used a standard 102-foot G5RV quite a bit, and am curious about the double and junior variants, which I've seen offered for sale, but never found any technical analysis of them. Having read analysis of how the standard G5RV design works on different bands, I wonder if you can just have or even double the length and still have the design work for the same or the intended bands of the two variants. Are they legitimate? So good question, long question, but it's a good question, Rick.
It's a very good question. I looked into the G5RV. I like them because I especially like the junior because it's so easy to work with. I've had good luck with it on 40 meters on up. I've read some things about the 160 meter long one, the double sized one, and I haven't read much good about it. I have no personal experience with it because if I'm going to put up that much wire, I just go a little bit longer and use an off-center dipole. I don't think it scales to the. I have that's a suspicion. I have no proof of that one way or the other. And he's right. There's absolutely not much written on the double-sized one. There is on the junior. People seem to be pretty satisfied with the standard size G5RV and the G5RV Junior. But I haven't read much on the double-sized one.
Okay, and we've got time for one more question here. Unfortunately, we can't get to them all, but so Daryl is asking, do you use or need a tuner for an off-center fed dipole? The sales pitch is always no tuner needed.
I think you always need a tuner because you're tweaking the thing. You can spend all day with the length of the antenna or with the exact center portion of where it's going to go. If you've got something that's up 40 feet in the air, you have to take it down every time and do that. Just a lot easier to use a tuner. I don't buy the sales pitch.
Roger that. Okay. And yeah, I agree. The couple times I've done an off-center fed, I've always had a tuner. And unfortunately, folks, that's all we have time for. A lot of other good questions out there. You can contact Rick at the email address there on the screen if you would like to get a copy of his presentation. And with that, I want to thank everybody for being here. Great turnout, great questions, and a lot of good content there from Rick. So thank you all for attending our Hamcation special event, and hopefully we'll see you here in person next year.
Okay, well, thank you very much. I appreciate the turnout, and I really appreciate the questions. Thanks very much. 73.